Tim, and thanks for having me. So I guess you can hear me clearly well, right?
Yeah.
Okay, cool. Okay, so again, it's my honor to present big data and its trends here at Pacific State University through Zoom. So today I'm gonna present it with the content. So like I'm gonna start with introducing myself and then big data, and also I'm gonna briefly introduce the predictive analysis adopting big data as well. First of all, I've been teaching at California State University, Los Angeles since 2002, and I also went to USC, computer science and computer engineering, master's and PhD respectively. And you know, I'm pretty sure many knows where the Caltech LA located at, but you know, if you look at the map of the Los Angeles area, assuming that there's a Pacific Sea here in the west side, there is a UCLA. In downtown, there is a the USC. I mean, south of downtown, there's a USC, and in downtown, there's a Pacific State University. And if you go to east more, you can see Caltech LA. And also, I've been working many companies in Hollywood, such as Warner Bros., C Research, and E Entertainment. Especially in Warner Bros., I've been involved in Matrix online game, and I've been working with the data integration and e-business application over there. Also, with the friends over there, I work at C Research as a consultant for the project. From there, I've been working on many, again, data retrieval or data integration projects. Simply, the search engine is the major system that I've been working to find out the right business based on users' needs. So when user try to find out, for example, Starbucks near my place, then you could use cresearch.com. That is actually a competitor of Yelp.com. So from cresearch.com, I actually get exposed to big data system because it has like millions of data. I mean, there is a millions of business in the States, and each business has its own business profile. Plus, there are customers' reviews about this business. For example, the C Research need to keep the users' review about the Starbucks near Pacific State University, for example, and then star rating about the service and the cleanness, etc. So since there are like millions of business profiles plus the review information, it becomes like a huge, like a massive data set, and it wasn't easy to store and process those data sets using the traditional system. So there was like a 12 years ago, like 10 years ago. Yeah, it's like 12 years ago. And then at that time, the big data concept just came to the industry, and I was exposed to big data to handle it. So when I was interested in using big data system for large scale data sets, I partnered with many companies, the many leading companies for big data, such as Cloudera and Hotmail. Also, the big data system needs the multiple servers. So I was partnering with the cloud computing companies such as Oracle, Amazon AWS, and Microsoft Azure, and IBM Cloud, etc. So those are companies that I've been collaborating with. Also, there is like a BI tool company such as Click and Tableau, because for data analysis, the visualizing the data and the location and time are very important to make people understand the meaning of data and the trend of data, etc. So based on that, I also collaborated with like a university such as USC and Penn State, especially with Dr. Sono Kim, and also the City of Los Angeles and LA Fire Department and Los Angeles Zoo, and companies like Softgen and others. So those are kind of my background, how I got exposed to big data. So I'm going to move on introduction to big data. So as you know, currently we have been experiencing data issues because we have too much data every day. That is greater than the gigabyte or terabyte or petabyte. That is because we have too much web data. Also because of IoT. The IoT is basically there are sensors that generate the data. Also, there are streaming data, and that is actually a smart thing, like a smart city and smart factory, because they have sensors to check out everything, like a temperature, voltage, or currency, the value, etc. Also, social computing such as Facebook and Twitter, smartphone, online games, that also generate too much data every day. And even at this moment, many of you are using the smartphone, I guess. And even though you don't recognize, your smartphone also generates your location information and many information about you and send it to many app companies as well. Also, bioinformatics data that has like a petabytes of DNA data, etc. So simply we have too much data, too much massive data, and that actually causes many issues, especially with the legacy approach. I mean, with the legacy system. So using the legacy systems, you actually can store this massive data set. Also, you can process it by using many CPUs and by increasing your memory size and storage size. However, the problem is it is too expensive. You can do it with the existing systems, but I mean, you need to spend millions of dollars. So it's like, you know, in the traditional approach, if you have a Canon, and if you want to improve the performance of the Canon, then you actually need to make much better Canon that is much bigger and much more expensive. So this is the traditional approach, right? So again, if we come back to the larger scale data set, it has the characteristic of the data that is it is too big, and the data structure is non-structured or semi-structured. It means that normally the data is structured using the legacy database to have a schema, but this kind of data that we are experiencing doesn't have any structure or the semi-structured. And also it has a characteristic of a 3V or BV. Like for example, velocity means the data is generated. I mean, you have a streaming data that is generating continuously and quickly. And also the volume, simply the data is big. And also variety means that there are many kinds of data. It is text data or media data, like a speech data or the video. So again, traditional system that you have can handle them, but it is too expensive. You need to spend like millions of dollars. So simply, whenever it becomes too expensive, we can say the legacy system doesn't work. Therefore, we need a new system that is not expensive, but it can also handle this larger scale data. So basically, the issues we meet here is how you can store and compute this data. Okay? So we have a massive data set, and how you can store and compute it. So the company like Google, they met this problem like a long time ago because they need to gather the web data from all around the world, and they need to index it for their search engine. But they realized that the traditional system is too expensive to do it. So around the 2000, around 17 years ago, they tried to address this issue. The first to store this kind of large scale data set, they built their own file system called GFS. That is actually Google File System. That is a distributed system using non-expensive commodity computers. Means like they simply use many Linux servers. So they made a distributed file system with like for example 15,000 Linux servers. So they cluster them together and then make it like a single system. Similarly, to process and compute large-scale data, they adopted a MapReduce engine. That is actually parallel computing. Same using non-expensive computers. That is actually Linux servers. So to store and to process and compute this kind of large-scale data set, they have the function to store and to process with a multiple cluster. Simply, they developed their own supercomputers as a distributed parallel computing system. After then, they tried to, so the Google simply can handle the web data and make their search engine works well. So they want to show up their solution. So they published the papers in 2003 and 2004. So many people was very impressed at reading these papers, and that is kind of motivation to start the big data platform in open source community as well. Yeah. So if you will look at distributed parallel computing system again, it's like you have like thousands of gunmen. So each gunman, it is simply a gun, but when it is composed of 10,000 gunmen, it becomes very powerful. Yeah. So you can read like 10,000 of gunmen who works together. It becomes very powerful, and it's like you combine. You have like for example, 100 guns together to be a very strong like a weapon. So in the view of a computer, it's like this. You have like multiple servers that has a CPU and storage together, and then these servers are connected through a network. So so we can call this as a cluster. So each cluster has at least 4 servers or like 15,000 servers. And they are all connected through networks. So even though it is like 15,000 servers, it works like a single server. So physically, it's like 15,000 servers, but logically, it works as a single server. Yeah, so this is the structure, the architecture of big data. So basically, this is not the new concept because supercomputer, the traditional supercomputer has the actually same concept, like the supercomputer is distributed parallel computing system. But the difference is traditional supercomputer has a group of storage and also a group of computing engines together, and they are connected through network. It works well for small data size. However, if data becomes bigger, like if your data is greater than gigabyte or terabyte, when your computing engine tries to gather data to process, it takes sometimes more than 20 minutes. So when you process your data, if it takes 20 minutes, your system doesn't work. But if you come back to right side as a big data architecture, you can see, for example, your Linux server has a CPU and storage together. So whenever you distribute your data into the storage of each Linux server CPU can easily process and compute data. And then the result, only the result can be exchanged through the server. So there is not that much bottleneck through the network. And so the big data architecture is working well for large scale data sets. But nowadays, especially for cloud computing also provide big data services. And then they use a high-speed network. So even though the cloud computing use a traditional architecture of a supercomputer, it still works. I mean, it works for large-scale data as well. Yeah? But mostly in the beginning, each server should have a computing engine and storage in the same machine for big data architecture. So if we come back to big data again, we should know the definition of a big data. So people normally define big data as a 3D and 4D as a data's point of view. But from now on, I want to say that you should consider big data as a system instead of the 3D or VV and 3D or 4V. So we can say big data is a non-expensive platform or system, which is a distributed parallel computing system, and which can store a large scale data and process it in parallel. Okay? So I hope from now on you can take big data as a system, not as a data. Yeah. So the most popular solution for big data is Apache Hadoop. Again, this is not expensive supercomputer, but still supercomputer, and it can handle a massive data set. And also, it is more public because it is open source. You can download it and install it to your clusters. So it means that nowadays, anyone can own supercomputers. So even you work at a university lab or small companies or small research centers, you can own a supercomputer by installing Apache Hadoop. At the same time, there are many other solutions as well, such as Spark. There is in-memory processing. Basically, Spark is integrated into Apache Hadoop as well. And also there's a NoSQL DB such as Cassandra, MongoDB, Redis, etc. And there's also search engine called Elasticsearch. So those are kind of big data solutions that people have been using. So briefly, the Apache Hadoop project was starting around the January 2006 after the Apache community have read the papers from Google. And Apache community, especially the people who worked at Apache, Lucene and Notch, project. Those are like a search engine. They are interested in the Google's file system and MapReduce. So they started the Apache Hadoop project. And I'm pretty sure many of you have seen this yellow the elephant. That is the icon of Hadoop. And this is actually, I mean, Hadoop is actually the name of the elephant toy of this gentleman, Doug Cutting's son, because Doug Cutting was leading this Hadoop project, and he named it as his son's elephant toy. Also, this big data system, especially Hadoop and Google's approach, is linearly scalable. So, for example, you can start with 4 servers as a single cluster to handle, for example, gigabytes of a data set. But the bigger your data, the more the server you can add into your cluster. So if your current software works well for a small cluster, in theory, it works with a large cluster as well. Okay? So we can say it is linearly scalable. So your software, for example, your data analysis software works well with 3 GB of data set. That software should work with more than 200 terabytes of data set by adding more servers. Okay? So it is called linearly scalable. So the bigger your data set, the more server you can add, and your system still works well. So when you meet, I mean, sometimes you can see some war because some people consider big data as just data, the large scale data. Then if you have a software that works with Hadoop cluster, for example, then they may complain. They may challenge you if you make your server works with 3 GB of data. It's not the big data, but again, they don't clearly understand what the definition of big data. So that's why they said it's not big data. But if your software works well with 3 GB of data in a Hadoop system, by adding more servers, that system works well with a much bigger data set. Okay? So I guess I'm trying to say the big data is the system, not the data. I mean, not the data size. Okay, so the big data has been popular for the last 10 years for business because again, even though you are working at small companies, your small company has a supercomputer, and also your company, normally the business has a valuable data such as customer data and operational data. Means you have your own specific data. A big company has their own data, but they don't have your data. They don't have your specific data. So it means that once you have your specific data that is proper for your specific domain, you can find out the value from those data. So for example, if you use your customer data, that can be adapted for smart marketing and sales, and also for advertisement. And also your operational data can be used for smart things, such as smart factory and smart city. Okay? So that's why using this big data system, people are trying to find out value and profit. So I just want to show you some example. Like this is a map. This is the data map. I mean sentiment map of the event called the AlphaGo game. Like several years ago in Korea, the Google AlphaGo competed with the Go player, human Go player, and they beat the human player 4-1. And it was very sensational because Go game is much complicated than the chess. And then at that time, we collected the data from Twitter about this event, and then we tried to analyze the sentiment, and then we do template spatial analysis to show what the people's reaction about this event. Okay? And similarly, this is the dashboard for Korean presidential election, and this is just to adapt to Elasticsearch to show who get tweets from Twitter data for about this presidential election. Okay? Also, this is to analyze the business in Los Angeles to show which business is popular by collecting data from public sites using Apache Hadoop system. And also, this is a traffic data analysis using Waze dataset. I'm pretty sure many of you know Waze. That is a navigation app to gather the data from users. So drivers who has this app, they can report the traffic or any construction around the driver, and then the Waze collect those data to share it with many other users who use Waze app. Also, the Waze app itself in the device generates data to show if there's any traffic jam from the driver's device. Maybe at this moment, I just want to simply show you how okay, give me a sec. I just want to share this. This is actually a 3D map that shows how the traffic has been changed from the data from the device. That is also implemented using Hadoop system. So this is temporal spatial data analysis, like based on time. For example, January 5th, when the time passes, it shows the traffic. And this data is actually gathered from the Waze app device. So as a LA City decision maker in the traffic division, you could find out when and where the data has been, the traffic has been jammed. So you can make some decision based on this to plan your traffic plan. Let me go back to my PowerPoint slide. Okay, so basically, using for big data system, you can use many solutions like Hadoop and Elasticsearch and NoSQL DB. And so this area is divided into many categories. So, for example, it needs a data engineering, like a big data engineering, to collect the data. Also, there's a big data analysis area. Once you gather data, you actually need to filter it to make your data much cleaner and to make the data analysis easily analyze the data. So this part is actually related for data engineering, especially for big data engineering. After then, you need a big data analysis to find out the insight of the current status. So you can just see what's happening right now. That is big data analysis. And also, once you have a data, you can predict the future. So using machine learning algorithm, you can predict the future to find out what is the future trend and what should be the future the traffic, what should be the if this is fraud or if this customer needed this kind of items or not. Okay? So it needs big data science. And also the data visualization is very important because the people want to see visual results. Okay? So those are kind of the area that the data and big data community are interested in. Simply, there are like a position for this area. So now let's move on the predictive analysis in big data. So far you have seen the data analysis is possible using big data systems. That is mostly to gather data and to analyze it to see the current insight. Also, there's a big data science that is to predict the future trend and pattern, especially with the massive data set, but it needs a machine learning approach. Mostly the people are into Spark. So far you have seen Hadoop and other like solutions, but the Hadoop system has a limitation, especially with the MapReduce services, because it's really hard to write code in Java for MapReduce functions. Also, it has some performance issue, even though it is a parallel computing. Also, there is performance issue as well for intermediate data that is generated between map and reduce. That is painful, especially for machine learning algorithm, because machine learning needs a lot of iteration. But if you have too big intermediate data, it's really hard to get the performance. I mean, if your system becomes very slow. But fortunately, the Spark came out that is built by UC Berkeley AMP Lab by Matai Jaharia in 2009. And then this lab actually make it as open source in 2010. And it is in-memory processing, that is to store intermediate data into memory. It means comparing to Hadoop MapReduce, it becomes 20 to 100 times faster. And this is really good for machine learning. So Spark provides a machine learning service. And it can, so if you use Spark machine learning code, you can build a prediction model. Okay, so many people have been using Spark machine learning for big data science and prediction analysis. And as you know, around 2015, deep learning came out, especially Google TensorFlow library came out for deep learning. That is to use GPU and CPU together. And in GPU, there are multiple cores. It's like parallel computing in a chip. So in big data, you have seen distributed parallel computing, but in deep learning, in GPU, you use a single chip and it is composed of multiple cores. So it's parallel computing, but in different approach with the big data. So once TensorFlow library came out to make people, the developer, easily to write deep learning application, many other companies provide many deep learning libraries such as PyTorch, Keras, Kappa, etc. So the deep learning, there are many approaches. That is basically based on neural network for predictive analysis. So deep learning is one of a machine learning approach, but instead of using the traditional like a mathematical approach, deep learning used neural network. And then it has many kinds of approach, such as convolutional neural network, also recurrent neural network, including long short-term memory, also GAN, generative adversarial network. So briefly, convolutional neural network CNN is a good fit for image recognition and video analysis, and recurrent neural network RNN is good fit for time series prediction and text analysis. And GAN is kind of a CNN is good for image synthesis, such as fake faces. Yeah, so you can generate new faces using multiple people's face. And there is a scholar named Andrew Ng. He is very famous in deep learning community. And around 2016, he provided us very interesting chart. It shows that the larger the data set, the better accuracy the deep learning neural network. So whenever your neural network has more cells, I mean, the larger your data set, the better accuracy your neural network has comparing to traditional machine learning algorithm. It means that for big data, neural network is neural network has much better prediction. Okay? So this is very interesting. But there is actually a gap between deep learning and big data because deep learning community, they use a single server with one or two GPU with CPUs. But big data community, they use cluster that is composed of multiple servers, and each server has CPU cores. And big data has been popular in the market for last 10 years. So whenever you have a large scale data, the company already have used the big data cluster to gather data and to analyze and predict it. So if you use a deep learning approach, then like when you have a big data cluster, and if you have a expensive server with a GPU, still to use existing large scale data, you have to gather data from a big data cluster to your GPU server. But when you have a large scale data, it takes really long to take data from big data cluster to your server. That is actually happen for traditional system as well. Some people who use traditional machine learning using R and Python, and if they want to use existing large-scale data, they also need to take data from big data cluster. That takes forever. So the gap between big data community and the deep learning community and traditional community is kind of an issue. So the big data community has an idea. What if we combine deep learning and Spark, big data prediction Spark simply, or the big data. So if your deep learning library is working well, I mean, if you integrate your deep learning into a big data cluster, you can leverage the existing big data cluster because once you have a big data cluster, you already have a solution for data engineering and data analysis and data science, and now you can even adopt deep learning. And you don't have any, with this, you don't have any gap to transfer massive data set from big data cluster to your GPU server. Okay, so simply you just you integrate deep learning into big data cluster to use existing big data the engineering or the science. Okay? So to integrate deep learning with the especially for existing Spark machine learning library and engine. For example, Databricks, the leading Spark community, proposed the deep learning pipeline. Also, Yahoo, they provide the TensorFlow on Spark. And Intel also provide the BigDL library, and which are all integrated into big data systems, especially into Apache Spark, etc. So Apache Spark, that is a good for in-memory processing and machine learning. You can simply add a library called distributed deep learning. Okay, so again, it is to leverage the existing big data services, and you can also find out new the value using deep learning. So the Spark is actually composed of many services, especially with the driver and worker. A driver is like a manager, and workers are like a parallel computing tasks. So once you have a data, each data is distributed into each worker, and each worker can compute the data. So simply you can build a prediction model using worker. And distributed deep learning library is integrated into worker, so you can use Spark for writing a distributed to write a deep learning service. So in this chart, in this figure, there are like multiple workers, and driver is to manage these workers to build the deep learning model, especially in Spark engine. So let's move on. Big data predictive analysis use case. So for example, this is one of my paper that is published today in the conference. We have a Amazon review data set. So Amazon sell many items, and the users rate the item, especially with the comment and star rating. So we want to predict users' star rating with the existing data that has a user star rating. So we want to use the famous machine learning algorithm ALS, alternating elastic scale algorithm for Spark ML. Also for deep learning, especially for distributed deep learning, we want to use a neural collaborative filtering, NCF. So we gather data from Amazon website, I mean Amazon AWS cloud. There is data between 2005 to 2015, and there are like 9 million total product reviews with a star rating, and file size is about 5.26 gigabytes. And if you use traditional system, if you use traditional single server, whenever the file size is greater than 5 gigabytes, normally it takes several hours, or sometimes you have a memory error. But using a Hadoop Spark system, it actually compute. I mean, it can build a prediction model without any problem. So we adapt those algorithms, and then we measure the performance. Like the performance here is the computing time to build a model and build a prediction model and validate it. So traditional ALS machine learning using train validation split approach and cross validation approach, it takes like 5 to 35 minutes to train and build the prediction model and to validate it. But using the deep learning NCF model based on a number of different batch size, it takes like about 15 to 33 minutes. So simply we can say the performance is kind of similar to between traditional approach and deep learning approach in big data systems. But for the error, the accuracy, so the smaller the error, it means that the better the accuracy is. So here the error is like a 0 to 1.8. It means that, you know, normally star rating is from 0 to 5. Yeah? So for traditional ALS in TBS and CB approach, the error is, the mean absolute error is about 1.5. Means if you say I want to rate, this user may rate this item as 3, but my prediction to say this user may rate this item as like a 4.5 or 1.5, because there is like a 1.5 error. Yeah? So the error is actually the difference between actual rating versus the predicted rating. Yeah? So the error is about 1.5 for traditional machine learning system. And using deep learning algorithm, the error rate is about 0.7. So if the user rates this item actually as 5, our predictive model says the rate is about 4.3. Okay, so the error is much smaller than the traditional algorithm when we use the deep learning algorithm. So again, this is motivated by the Andrew Ng's chart that shows that the bigger the data set, the more accurate using neural network. Okay. So in summary, I just want to introduce what big data is and how for predictive model, Spark ML has been used, and then how the big data community tried to adapt deep learning into Spark for distributed parallel computing system as a solution for big data. And also the distributed deep learning in big data system actually provide more accuracy, especially for the rating prediction with the similar performance. And it also leverages the big data cluster because we can easily access large scale data set in big data cluster to build a prediction model in distributed deep learning. Okay. So this is all I want to present today, and I hope it's helpful. And does anyone have any questions?
Okay, thank you so much. So this is a really interesting the talk, and then big data is so important these days, and then especially the state of the art technologies, they changes in every day. So mentioning some trend in big data and machine learning, I think that is really important. So student, and then if you have any questions, just feel free to ask. So yeah, even though you don't know much about this field, but still you can ask any questions.
Excuse me, sir. I mean, you mentioned that the distributed deep learning. So, I mean, which algorithm you are going to use? I mean, the best scenario.
It depends. So, for example, the
RNN or CNN or something like you are talking about.
Yeah, again, it depends.
Yeah.
Depends on what you want to predict. you need to use CNN or RNN, or you need to use.
So
yeah,
you
go ahead.
mentioned that you work for the AWS. So I mean, I'm doing that. That's the same. The AWS book recommendation system. So neural collaborating filter is the best. I mean, but you were saying that the ALS. I mean, that one is the best. I mean, the
So
algorithms you are used.
For predictive analysis, you actually need to build many models using many different algorithms,
Mm-hmm.
and then you have to select the best result. I mean, you have to select the model that shows the best result. So in this example, I need to select the NCF model because it shows much better accuracy.
Yeah. That's
So it
this
is
is the
based on your experiment.
Yeah. Okay. All right. Thank you.
Sure.
So any other questions?
Is it possible we can get this lecture? How can
this
get
question for Dr. Kim, right?
Mm-hmm. So you want to have some kind of the slide from
yeah this kind of a slide?
So it depends, the Professor Wu is willing to share it.
Oh yeah, I will share it with you.
Okay.
I could share it as SlideShare and give you the link to Professor Kim.
Mm-hmm. Okay, thank you so much. And
Sure.
then also one some kind of common question is, so these days, pretty much all the students, they want to learn about big data and want to learn about machine learning, but many times they are overwhelmed by the some kind of new topics, new technologies. So what can be the best way to start the machine learning and then the big data for students?
In my case, I just provide this course to my students because I know there are like a huge job market for this. So simply, as a student, I think they need to take this kind of course at the university. Then it will be much easier.
A single course, because it requires lots of materials to study. So for example, data analysis can be one course, and then Hadoop and big data is one course. Machine learning can be another course. So there can be many courses, right?
Yeah. So for me, to make it efficient, I have two courses. The first course is for big data using Hadoop. And also second course is big data science that use the Spark for machine learning.
I see. Okay, so you summarize, all the knowledge in two courses, and then you are teaching these two courses as a kind of series.
Exactly.
Okay, that's
so I realized that it works well.
Yeah, because many schools in the world, there are too many courses. So yeah, running all those is really challenging.
Yeah, agreed.
And then okay, the student, and do you have any other questions? No? All right, then, thank you so much again, Professor Wu. So this was very helpful. And then, I really appreciate your time. And yeah, hope you can enjoy your stay in Korea.
Thank you, and thanks for having me here.